as you can see, we are in this chapter starting to talk about three-dimensional figures, and we will start simply by talking about the vocabulary of those three-dimensional figures, and then tomorrow we'll start finding the area of those figures, and when we return from break, we'll be talking about the volumes of these figures. The chapter we just finished is tremendously important in order for us to be able to find the area and volumes of these figures. Once again, let's put these phones away. We're starting a new chapter. Let's get focused. Okay, so there are polyhedrons, and then there are other stuff. So as you can see in our notes, polyhedrons have line segments, and they have surfaces that are polygons. So what would be an example of, let's start with non-example. What would be an example of something that is not a polyhedron? If its faces have to be polygons and its edges have to be line segments. What would be an example of something that is not a polyhedron? Right? Give me something that is circular that's three-dimensional. A sphere, absolutely. A sphere is not a polyhedron. There we go. Matthew, you were about to give me a non-example. A cylinder. Something else you can think of? Something else? Yes, ma'am. A cone. Okay, so what would be common examples of things that are polyhedrons? A pyramid, absolutely. What else? Cube, or more generic, pyramid and prism. Okay, so in this course, the figures that we're going to be talking about finding the surface area and volume of are those shapes. Everything else kind of falls outside of our requirements. So, as I mentioned before, in a polyhedron, the surfaces are all polygons, and I think I kind of accidentally said it. The surfaces are called faces of the polyhedron. The intersection of those surfaces are called edges, and the points where three or more of them meet are vertices. Yes, good. Okay, so on the screen, they have drawn a cross-section for us. The plane is slicing that cone vertically. What cross-section is formed? A triangle. How about kind of just trying to take this to the next level? Suppose I were to take that cone and slice it horizontally with a plane. What cross-section would I have? Circle. Still getting really wild and crazy here. How about if I sliced it kind of on a slant? What kind of this? If I were to slice this on a slant, what kind of cross-section would I have? It wouldn't be a circle, definitely not be a triangle. What I'd be looking at would be an oval. It is not a circle. Actually, the proper term that you're going to see next year in Algebra 2, the proper term is an ellipse. Okay, so just kind of throwing that out there, and you'll be writing the equation of that and graphing that next year. Okay, in problem 4, that's a your turn. Please take a moment within your group and identify those cross sections. Drawing a cross section. And once again, I know it's kind of a pain. That's why there's only 3 of them in your homework. So in problem 5, we are asked to draw the cross section formed by a vertical plane intersecting the right and left faces of the cube. So this is the right face, and this is the left face. I want a plane that's intersecting those two faces of these two faces of my cube. And what am I guaranteed that it will be? A rectangle. It could be a square, but it would be a square if I was slicing it perfectly halfway. Whereas, kind of, if my plane is slicing here and here, you see that it would not be a perfect square. Cross section would be a rectangle.